Hi guys. So we're going to be starting our last learning target for the first semester, and that is going to be on systems of equations, okay, solving a system. So what you're looking at is a graph of a quadratic, okay, so that's your y equals x squared minus 2, and a linear y equals x. And one of the ways that you can solve a system is by graphing the equations and then looking for points of intersection. Because when we're talking about solving a system, you're looking for points that are solutions to both equations. So if it's a point where the two equations intersect, then those are going to be your solutions. Okay, so on this graph, I have y equals x squared minus 2 and y equals x. So I've got, here's one point of intersection, which is 2, 2. And then my other point of intersection is -1, -1. Those would be the solutions to my system. Okay, it literally is as easy as that. So again, and there are multiple methods. You guys actually learned different methods when you were in Math 1. Um, there's things like solving by substitution, solving by elimination, equal values method. Because of our short amount of time this year, we're just going to focus on only solving by graphing. Okay, so once again, our solutions to this one would be 2, 2, and -1, -1. It would just be where the two lines intersect. Okay, and for the rest of this, I'm actually going to use the graphing calculator because that's what you guys are going to be using for your skills check. So okay, guys, so we're going to pick up with where I left off. And I said we are going to continue doing this by using the graphing calculator. So, looking at a version of the graphing calculator, if I were to give you two equations, you would just enter the two equations into your calculator and then look for the points of intersection. Okay, so I'm going to put in two of them, and these are found in your notes packet that is shared in the agenda. Okay, so the first one is going to be y equals x squared minus 5x plus 7. And then our second one is going to be a linear, so 2x plus 1 and graph. Okay, so now a couple things about your graphing calculator. So one, it's you can't see the second point of intersection. You're going to be using a feature on your calculator for this one anyway, but you should know how to change your windows. So if you go to Window up here, it's next to your Y equals button. I want to actually let's look at our graph. I want to see higher up. Okay, so right now my graph only goes up to 10. I want to make it go higher so that I can see what's going on. So I would go to my Y max and I'm going to change that to 20 and we'll see if that gives us enough. There we go. Okay, so now I can see both parts of both intersection points. So instead of just guessing what your points are going to be, you're going to use a function under trace. So where we did minimum and maximum before, we have this option called intersect. Okay, and since we're looking for the intersection points, that's what we're going to choose. So intersection, so just like before when you do left bound and right bound, this one's asking for the first curve. As long as it's on one of the two graphs, you're on a curve and you hit enter. And then it puts it on the second curve. And then you hit enter and again you hit enter for guess. And my first intersection point would be 1, 3. Okay, now I'm going to do the same thing for my second intersection point, but I'm going to move when I go to choose intersect, I'm going to move my cursor closer over to that second point. Okay, so now I'm over to closer to this one. So I'm on my first curve. I can hit enter. It moves it to the second curve. I can hit enter. I hit enter for guess. And my second intersection point is 613, which means I have two solutions. Okay, I have two intersection points. So I have two solutions. My first intersection point and therefore first solution will be 1, 3. My second solution is 613. Okay, so that's how you find the intersection points on your calculator. So now let's take a look at one that has two quadratics. Okay, just so you can see what that looks like. Okay. Why is this not? All right, let's just hit clear for all of this. Sorry guys, I don't know what's happening here. Okay, so now I'm going to type in 2 quadratics. So I have x squared plus 2x plus 3. And then my second one is going to be another quadratic this time. So 2x squared plus 2x minus 1. And hit graph. All right, so now you can see that I have 2 quadratics, but I don't solve this any differently. I'm still looking for any intersection points. And in this case, I see 2 of them. I see one that's right here around what looks like -2, 3 maybe, and then one over here that's possibly at around +2. But we're going to use our calculator and that intersect function to calculate those intersection points. So I'm going to move a little closer to one of my intersection points. So I'm just move close to it. Hit enter for first curve. It will move it automatically to your second curve. Hit enter for guess. And again, I get my intersection point at -2, 3. Okay, so that's one of my solutions. To find my second one, I'm going to go back to second trace, go down to intersect, and I'm going to move it closer to my other point. Hit enter, enter for second curve, enter for guess, and I get 211. Okay, so those would be my 2 solutions for this one, -2, 3 and 211. Now, and I'm gonna if I leave my first one in there, and this is it's a little glitchy. All right, if I type in something like let's just do -4 and see what that looks like. I just want to give you an idea. Okay, so now you can see how I have a graph up here and I have my second graph down here. Since there is no intersection points, that would be no solution. Okay, they do not have any points in common, so you cannot find a solution to that one. There isn't one. It does not exist. Okay, so basically, if you're given 2 graphs, you're looking for the intersection points. If you're given 2 equations, you're going to graph them and then find the intersection points. And that's as much as we're going to get into systems for this learning target.